Okay, in this section we're going to be doing what are called optimization problems. And optimization problems mean we either want to find a maximum or a minimum of a function. We want to optimize something. So think about it. If you're a company, you had a company and you were making something, you would want to maximize your profits. Or maybe you want to minimize how much materials you use to make something. Okay, maybe you want to maximize how much volume you get out of a box. So those kind of things. So it says, in this section we will use the fact that when a function has a maximum or minimum, the derivative is 0 to solve application problems that are looking for a maximum or minimum value. So here are some steps to solve these problems. So step number 1, determine the quantity that you're trying to maximize or minimize. So read the problem and say, okay, what am I trying to find, the biggest of or the smallest? If possible, draw a figure to help you illustrate the problem. So 3, write a function for x, what you're trying to maximize or minimize, in terms of another variable of the problem. Okay, step 4, since we know that if you have a maximum or minimum, the derivative has to be equal to 0, you're going to take the derivative of the function you found and set it equal to 0 and solve your equation. So that's really steps 4 and 5. Now you're going to make sure you found a maximum and minimum using, remember where we made sign charts? So the first derivative, you'd put your value here, whatever it is, let's say C, and then you would want to make sure it changes sign. So if it goes from positive to negative, remember you have a maximum. And if it went from negative to positive, you'd have a minimum. So you want to check that. And then make sure you're answering what you were originally looking for. So we're going to do one here. So the big picture of these problems is that you're taking a derivative, you're setting it equal to 0. So this says, what's the smallest perimeter possible for a rectangle whose area is 16 inches, and what are the rectangle's dimensions? Okay, so we're trying to minimize the perimeter. So let's draw our figure. So say we have x and y, right? Then our perimeter would be 2x plus 2y, but we need to get this in terms of one variable. Now we're told that the area is 16. That means x times y is equal to 16. So if we solve for y, y would be 16 over x. So our perimeter is 2x plus 2 times 16 over x would be 32 over x. Okay, so here's the function that we're trying to minimize. So we're going to take the derivative, which would be 2. Think of this like 32x to the minus 1. So we'd get minus 32x to the negative 2, which is 2 minus 32 over x squared. So now to find our minimum, we want to set this equal to 0. Okay, to solve this, we'd multiply through by x squared, so we'd have 2x squared minus 32 equals 0. Add 32 to both sides. Divide both sides by 2. Take the square root, we get x equals plus or minus 4. Now negative 4 makes no sense here because we're talking about a length, so we're going to try x equals 4. Now let's check our first derivative. So if we plug in something less than 4 like 0, it's undefined. So let's plug in 1. So if we plug in 1, we'd have 2 plus 32, which would give us 34, so that would be positive. Oh, sorry, we want to plug it into our derivative. 2 minus 32 would be negative. Okay, and we plug in something like 5, we'd have 2 minus 32 over 25, which is positive. So we do have a minimum here. So minimum when x equals 4. So that would also make since y is 16 over x, that would be y equals 4. Okay, so this actually ends up being a square, which remember squares are rectangles, so that's fine. Now, what it actually asks us, it says, what is the smallest possible perimeter? So that's saying, okay, we found where it's the smallest. We're going to do P, the original, the perimeter at 4, right, which would be 4 plus 4 plus 4 plus 4, which would be 16. So 16 is the smallest possible perimeter. The dimensions would be 4 inches by 4 inches.